Good morning, everyone. So yesterday we talked about ionization, the process of making atoms into ions by causing them to lose or gain electrons and become either positive cations or negative anions. And we talked about how this is a natural process, happens all the time in your body and in other substances too. But we also talked about how X-ray radiation or any kind of radiation has enough energy to make ionization occur in atoms in your cells on a large scale in an unnatural way and potentially cause damage to the cell and disrupt the cell's metabolism, potentially leading to the death of that cell. And today I want to talk about, well, what determines if a cell will be harmed by radiation? And that to talk about that, we need to talk about a cell's what is called radiosensitivity. So here's the rule. If a cell reproduces a lot, it doubles itself, makes a new baby cell very frequently, then it's got a higher chance of being harmed by radiation than if a cell is stable and not reproducing. That's not to say that a cell that reproduces isn't stable, but if a cell is not reproducing, if it's just living its little life all by itself. So cells that reproduce a lot, very sensitive to radiation. What kind of cells reproduce a lot? Here's a couple. White blood cells. Your white blood cells die pretty frequently, and you're constantly making new. And because of that, they're pretty sensitive to radiation. Here's a white blood cell in the midst of a bunch of red blood cells. Another kind of cell, bone marrow. Not the bone tissue, but bone marrow inside of the bone. Reproduces a lot and very sensitive to radiation. And the third are reproductive cells. Sperm and egg cells. They reproduce quite a lot. Here you actually see an egg that is surrounded by sperm cells, and because they reproduce a lot, they're very, very sensitive to radiation. Now, which kind of cells have low radiosensitivity? And I should define here, radiosensitivity is a definition or a term used to describe how sensitive a cell is to radiation harm. If you have low radiosensitivity, you're not easily harmed. And if you have high radiosensitivity, you are easily harmed. So cells that are not easily harmed by radiation, mature bone tissue. It's there. Those cells are alive. They're living in bone, but they are not reproducing a lot, so they are not easily harmed. Muscle tissue, not easily harmed. Nerve tissue, not easily harmed. Here's an example of bone, a microscopic view of muscle, and a microscopic view of nerves. So all cells, if you look at this, you probably can see that double helix here. This is DNA. All cells contain DNA. Every single cell in your body has DNA. DNA is the hereditary material. It's got the genes in it that tells you everything about you, that tells your body how to do things that make you you. So DNA has that hereditary material that's passed down from one generation to the next. So here's a set of chromosomes, and on the chromosomes are genes. Here's one set of chromosomes. Here's a gene there, these two red bands, two green bands, two blue bands. Every chromosome you have two copies of it and two genes. And those genes pass on the heredity information. If the genes are altered, that's called a mutation. Some mutations are good and actually help the organism. Many are harmful and result in disease or problems. And the whole thing that we want to talk about with this is that mutation, something caused that. And that mutation could be caused by radiation, by X-rays. So here's some mutations. This person, actually, look at this, actually has an extra digit on a hand. This poor little baby, actually the legs did not form into two legs. There's one leg. And these are mutations. There are many causes of mutations, a few causes. Diseases can cause a mutation. If the mother or father has the disease, they can pass that on to the infant. It can cause a mutation. Radiation, X-ray exposure, can cause mutations. Whether it's from X-rays, gamma waves, it's from ultraviolet light, all these things could cause mutations, changes in the DNA that could then potentially be passed on to a child, or changes in the DNA of that developing fetus itself. Chemicals can cause mutations. You live near a factory and you're breathing in those chemicals every day. It could cause mutations in your DNA. In fact, that's a greater risk than radiation exposure. So all these things can cause mutations, and the reason why I mention mutations at this point is because that's one of the problems with radiation exposure. It can cause mutations in your DNA that could lead to diseases. So look at this schematic. This is a diagram that shows the sources of radiation exposure. So you're exposed to radiation all of the time. And where does that radiation exposure come from? The number one exposure to radiation is the sun, because we are getting ultraviolet radiation and visible light radiation from the sun all of the time. That's the number one exposure to radiation. Other than that, the number one source to radiation, if you look at this big yellow piece, 55% of our exposure is from radon gas. Radon gas is a naturally occurring gas that builds up in the ground, and our exposure to it usually comes from buildings that are built with a basement that are in an area that have high amounts of radon gas in the ground. And then that radon gas builds up in the basement and you're exposed to it, and it can cause mutations, can cause cancers. If you're in a high radon area, there are radon detectors that you can buy and find out if there's high amounts of radon in your basement. If there are companies that will come and do things to remove that radon gas, to pump it out of the basement. Second source, natural sources excluding radon. Here it is, 26% of our exposure. Third one, medical x-rays. 11% includes dental procedures and includes procedures at a hospital, a ER, or whatever. If you think you had a broken bone, all of those things are 11% of your exposure. Nuclear medicine. Maybe you have cancer and they've given you some kind of nuclear medicine to help to treat that. That's 4%. Consumer products, 3%, and other things like nuclear power plants and fuel and things. Occupational exposures on the job, exposures are less than 1%. So the thing to understand here is just that radon gas is our big exposure, and it's a naturally occurring element that is in the ground. Now to finish this area, what determines the amount of injury a cell can receive from radiation? We already know that if the cells are reproducing a lot, they have a greater chance of being harmed. Well, what else determines how much harm they can get? One, the dose rate. How big a dose of radiation is the cell getting? Of course, the bigger the dose, the greater the chance of harm. Two, what areas of the body is receiving the radiation? A greater area exposed, a greater effect on the individual. This is why when you go to the dentist and they want to take an x-ray, they might put a lead vest over top of your chest because they don't want that area of the body to be exposed to the radiation. And lead is very, very dense and it stops x-ray waves. They might put a little tiny collar over top of your throat because they don't want your glands in your throat to be exposed to the radiation because they're sensitive to it. And in the lead little area, piece over top of your throat stops those rays. The relative radiosensitivity of the cell, of course, determines how easily they'll be affected. Like we said earlier, if they reproduce a lot, they're especially sensitive to radiation harm. The age of the cells. The younger the cells, the more easily they are damaged. Older cells are more stable. They're not damaged by radiation as easily. And the total dose of radiation. You can talk about the amount of dose, but then how much total over time dose. You want to keep the dosage to a minimum so that you don't have injury. You want to take retakes, keep retakes of x-rays to a minimum. You want to try to get the the picture taken right the first time on, say, on that tooth, so that you don't have to take a second picture and up the dosage rate that the person is receiving. And the organs that are receiving that radiation, irradiated is a term for receiving the radiation. Certain organs are more radiosensitive, like your reproductive organs, more radiosensitive than other areas of your body. So that is the end of the notes on radiation. We've talked about a lot of different areas, about waves, how the waves carry energy. The shorter the wave, the more energy it carries. We've talked about how an X-ray is made, how it's a radiograph, and the dark and light areas on the picture. We've talked about what makes an atom into an ion, how energy can cause that to happen, and how radiation can cause that to happen and cause cellular damage. And we finished with how radiosensitive cells are. And the thing to remember on this is that radiosensitivity is a way of talking about how sensitive cells are to injury from radiation. Cells that reproduce a lot are very radiosensitive.